Okay, we're almost there. We have one more to go over. I thought problem 2 was going to be a cakewalk, but unfortunately it's not. Your author used Minitab to do his work, and unfortunately our Data Analysis Plus does not give us an easy way to do the same thing. And so, what I'm going to ask you to do is to calculate the number 2 proportions by hand. Well, not the proportions, but the analysis I want you to do by hand. Let's first discuss what we're doing. In problem 2, we're asked to look at variables 10 through 17. These are the things like easy to return exchange goods, high quality, low prices. And as you recall, Springdale Mall really smoked everybody else on all of these except for, what was the one? Bargain sales, right? We had a bargain mall. Was it the West Mall that seemed to have those bargain prices? That was the one place that excelled. I think that's right. So in the parameters we'll be looking at in our spreadsheet are 10 through 17, and you're going to repeat the same work for each one of them. I'm going to do the first one for you, show you how it's done. We're going to look at easy to return exchange goods. And what the user is choosing is they're either going to mark 1, 2, 3, or 4. Whether they think Springdale Mall, Downtown, West Mall, or no opinion, 1, 2, 3, 4, best describes how they feel. So a value of 1 would be a vote for Springdale Mall. Okay, now let's jump back here. If we are going to have a null hypothesis, I should back up. We are not looking at the mean in this section. It's just like last week, where we first looked at the mean and then we looked at proportion. Well, in question 2 this week, we are looking at proportion. And so if we would expect each of the 3 malls to have the same ranking, we would say that the proportion that each gets would be 1/3, or 0.33. And we're going to make that our null hypothesis. We're thinking that each one of these malls has the same quality of goods, the same value, hours, help, all those things that we looked at. And so the alternative hypothesis is that this proportion is not equal to 0.33. Okay, unfortunately, we need to calculate this by hand, but let me flip back a few pages. Again, we have a two-tailed test, and pages 338, 339 go through an example that looks just like what we're going to do. Again, when we're doing proportion, we use the z-test. This is different than tests of the mean, and the test statistic that we will calculate, z, looks like this. It's equal to the proportion minus the hypothesized proportion divided by I got lost here. The standard error, the sample proportion. There it is. Wanted to get the right words. And again, this gets a little ugly for the math, but not too bad. Got a big square root in the denominator. Again, we look at the hypothesized proportion times 1 minus the hypothesized proportion divided by the square root of n. Okay. What we need now are some values. We have our hypothesized proportion. That's 0.33. Confusing, isn't it? Let me jump to the spreadsheet and show you how we get these other values. Sorry, the confusion here was mine. This is our hypothesized population proportion. P here, don't confuse that with p-value. This means proportion in this case. That actually should be a capital P. Does it look like one? Now it does. Is the sample proportion. So that's the value we need to go get. We need this sample proportion. Let's see. We have hypothesized proportion, and we need n. And you might say, isn't n 150? Well, yes, one of the complications of this problem is that n is not 150. Let's look at our spreadsheet. What we need to do is dig way back into week 1, where we used our histogram to get our frequency distribution. We're going to do that again. This is in Excel's data analysis, and it's called histogram. And we say OK. Let's see, do I have a bin range? Yes, I've left it here. Remember, these are the values that the response can take, and they were 1, 2, 3, and 4. Input values, I'm looking at column 10. We're first interested in who does the easiest exchanges. Okay. Let's see, I'll put this in a new worksheet. I don't need my histogram, the actual chart. I just need my frequency distribution. I say OK. And there is our data that we need. So, for ease of exchange, 72 people gave a response of 1. That's good old Springdale Mall. 2, what was that, downtown? 3 is west, whatever it is. And 4 was, I think, no opinion or something. Now, in order to get these stats to work right, we're not going to divide by the total number of responses, 150. We need to get a proportion based on only those people who voted for 1, 2, or 3, one of the malls. And so my proportion is not 72 divided by 150, but it's equal to 72 divided by, excuse me, I'm typing with one hand here, the sum of those who voted for the 3 malls, one of the 3 malls. There's the proportion we need, 62%. Of those who voted for one of the malls, 62% said Springdale is the place with the best exchanges. Okay, now we can jump back to our calculation. And again, I didn't go over the procedure. First, we're going to calculate that sample proportion. I just did that with a histogram. I modified it, though, by only looking at, I believe it's 116 of those 150 test or survey responses. Now I'm going to calculate the z-score, and we've begun that, and we can finish it now. Let's see. P, the proportion is, what was it, 0.62, right? Let's look back. There it is, 0.62. That's the sample proportion minus the hypothesized, and we're hypothesizing that it's 0.33. And even just saying that, again, the null hypothesis that everybody would get the same proportion. That's what that says. Each of them get a value of 0.33. Well, Springdale's sample gave us 0.62. Do you suppose we're ever going to accept this null hypothesis? Not likely. But let's run the numbers. Okay, so hypothesized proportion 0.33 times 1 minus 0.33 divided by, there were 116 values. I didn't put that in our spreadsheet, but if we just sum up those three values, and I'll put it over here. Let's see. I want a sum of these three things. Yep, 116 values. All right. Now, if I do this math, which I've already done, but I somehow deleted, let me run this again. Our test statistic turns out to be 6.56. Now we can make our decision whether or not to reject or accept the null hypothesis. Okay, we're looking at, for proportion, we use the normal distribution, and at the 0.05 level, we have 0.025 on each end, and that puts us at 1.96 and negative 1.96. Our test statistic is 6.56. It's way out here somewhere. Do we accept H0? Does our value fall in the middle? No, it does not. We reject the null hypothesis, and we say the population proportion is not equal to 0.33, and we accept the alternative hypothesis that it is something else. You are asked to repeat this procedure, the calculations I just made, for the other, let's see, values, numbers 11 through 17, things like quality of goods, low prices, variety, staff, convenient hours, all those things. And you may recall, and don't be surprised when you end up rejecting H0, that everybody is the same time and time again, because we know Springdale just smoked those other malls. I'll give you a hint. There is one parameter where Springdale was not the best. And I believe, yeah, I should confirm this before I say it. Yeah, I believe there's going to be one parameter that you look at where you are going to accept H0. All right, I hope that helps. I'm sorry that even our Data Analysis Plus could not do what we wanted to make this easy on you for this part. One last thing in part 2B. You are asked for the p-value. You can ignore that. We didn't calculate a p-value. What is a p-value? Remember, p-value is the critical value at this point. And actually, P turns out to be the area under the curve, doesn't it? No, we calculate what's called a critical value. And P, looks like I need a new marker. Turns out to be the area under the curve. Okay, again, you can ignore part 2B, calculating those p-values, because we can't do it, or it's very difficult to do. Okay, folks, I hope that helps. I'm here. I suspect you might have some questions. Give me a holler.